Before Canada had a flag, before provinces had borders, before cities rose beside harbors, there was ice. A frozen titan known as the Laurentide Ice Sheet buried nearly all of what we now call Canada. 3 kilometers thick in places. Heavy enough to press the Earth's crust downward. Powerful enough to grind mountains into sand. This was not weather. This was planetary engineering. For tens of thousands of years, ice sculpted a continent. And when it melted, it left behind something extraordinary. Nearly 891,000 square kilometers of inland water. Over 2 million lakes. Almost 20% of the world's freshwater reserves. Canada did not discover water. Canada inherited it, from ice, from tectonics, from deep geological time. This is the story of how geology built one of the most water-rich nations on Earth, and how that water shaped its economy, its power, and its future. Long before ice, there was stone. At the heart of Canada lies the Canadian Shield, a vast expanse of some of the oldest rock on Earth. These rocks are Precambrian in age, more than 2.5 billion years old. Granite, gneiss, metamorphic crystalline bedrock. This shield forms a bowl-like structure across much of central and northern Canada. Unlike sedimentary rocks, these hard crystalline formations are poorly permeable, resistant to deep groundwater drainage, structurally rigid. When glaciers scraped across this ancient crust, they gouged depressions into it. Because the bedrock does not absorb water easily, these depressions filled and remained. This is why provinces like Ontario and Quebec appear dotted with thousands upon thousands of lakes. Geology created the container. Ice filled it. At its peak around 20,000 years ago, the Laurentide Ice Sheet covered nearly 8 million square kilometers. Its weight pushed the crust downward by hundreds of meters. As it advanced, it bulldozed soil, flattened hills, deepened valleys, redirected river systems. Glaciers act like slow-moving rivers of rock-filled ice. Embedded stones scrape and polish bedrock beneath them. This process, called glacial abrasion, created U-shaped valleys, over-deepened basins, kettle lakes, fjords. When global temperatures rose, meltwater surged across the land. Enormous glacial lakes formed. One of these, Lake Agassiz, was larger than any freshwater lake on Earth today. As meltwater carved outlets, it shaped what would become the Great Lakes system, including Lake Superior. To the north, meltwater pooled into what became Hudson Bay, a massive inland sea still rebounding from glacial pressure. Even today, land around Hudson Bay rises nearly 1 centimeter per year. Canada is still adjusting from the Ice Age. Canada is bordered by the Atlantic Ocean, the Pacific Ocean, the Arctic Ocean. Few nations touch 3 oceans. This tectonic positioning places Canada at the crossroads of global maritime routes. The Atlantic connects it to Europe. The Pacific connects it to Asia. The Arctic, once frozen and inaccessible, is rapidly emerging as a geopolitical frontier. Melting Arctic sea ice is opening the Northwest Passage, potentially shortening global shipping routes between Europe and Asia. Geology positioned Canada as a marine power long before humans understood trade. Water flows downhill. Gravity does the rest. Canada is one of the largest producers of hydroelectric power in the world. Rivers like the St. Lawrence River, the Mackenzie River, the Fraser River have been harnessed through massive dam systems. Hydropower provides roughly 60% of Canada's electricity. This has profound economic consequences: lower energy costs, reduced carbon emissions, competitive advantage in energy-intensive industries. Aluminum smelting, for example, requires enormous electricity. Canada's hydropower makes it one of the world's leading aluminum producers. Water does not just sit quietly in lakes. It spins turbines. It drives industry. It fuels GDP. The Great Lakes form the largest freshwater system on Earth. Through the St. Lawrence River, ships travel from the Atlantic Ocean deep into North America. This system moves iron ore, grain, petroleum products, manufactured goods. Major cities like Toronto and Montreal grew because of access to water transport. Before railways and highways, water was the most efficient way to move heavy goods. Canada's freshwater geography shaped its urban development. Trade followed rivers. Industry followed trade. Water shaped settlement patterns. Cold waters off Canada's coasts are rich in nutrients. Ocean currents circulate minerals from the deep, supporting plankton growth. Plankton supports fish. Fish support economies. The Atlantic fisheries historically fueled entire coastal communities. On the Pacific coast, salmon runs remain ecologically and economically vital. Freshwater fisheries across inland lakes support tourism, subsistence, and indigenous traditions. Water feeds not just crops, but culture. Canada is also one of the world's largest resource exporters. Mining operations depend on water for ore processing, dust suppression, chemical treatment. The oil sands industry requires water for bitumen extraction. Offshore oil operations depend on Atlantic marine access. Water supports both renewable and fossil energy sectors. The geology that created freshwater also underpins mineral wealth within the Canadian Shield, rich in gold, nickel, uranium, and iron. Canada's geological history created a dual wealth: minerals below, water above. In a warming world, freshwater is strategic. Climate change intensifies droughts across many regions. Water scarcity threatens agriculture, industry, and stability. Canada holds nearly 20% of the world's freshwater supply. This makes it geopolitically significant. Water influences agriculture, energy production, population growth, international trade. In the 21st century, freshwater may become more valuable than oil. Canada holds one of the largest reserves on Earth. The Arctic Ocean is warming faster than most parts of the planet. Sea ice decline is opening new shipping lanes. The Northwest Passage, once trapped in ice, is becoming seasonally navigable. This could reshape global trade patterns. But it also brings environmental risk. Fragile Arctic ecosystems face pressure from shipping, drilling, and climate instability. Canada's northern waters are becoming a frontier, economically and environmentally. Water abundance does not eliminate risk. Flooding events are increasing in frequency. Glacial retreat alters river discharge patterns. Water quality faces challenges from industrial runoff. Management of such vast freshwater resources requires policy, science, and cooperation. Canada's water is not infinite. It is renewable, but vulnerable. Canada is not simply a country with many lakes. It is a geological phenomenon. 891,000 square kilometers of inland water. Over 2 million lakes. Nearly 20% of the world's freshwater. 3 oceans touching its shores. Ice carved the basins. Bedrock trapped the water. Oceans framed the continent. From this geological inheritance rose an economy powered by hydropower, trade corridors, fisheries, mining, and strategic freshwater reserves. Canada is not surrounded by water by coincidence. It was engineered by Earth itself. And in a century defined by climate change and resource competition, water may be its greatest advantage. Canada is not just a country with many water bodies. It is a country that was born out of water. If you found this documentary enlightening, subscribe, share, and leave a comment to support future educational content. This is the Geologic Lens. True stories beneath the surface.